In today's real estate market, accurately predicting housing price is crucial for making smart investment decisions. Housing prices are not determined by a single factor, but by a combination of property characteristics, location advantage, and neighborhood conditions. In this study, we use a dataset that includes factors such as property size, number of bedrooms, proximity to public transportation and essential amenities, crime rate, and average income in the area. The main goal of this project is to develop a regression-based predictive model that can estimate housing price based on these factors. This model can help real estate consultants and investors evaluate properties more effectively and make data-driven investment decisions. In this stage, we prepared the housing dataset by cleaning and organizing the data before applying any model. We use the rank widget in orange to identify which features have the strongest influence on house prices. Feature selection was not based only on ranking results but also supported by the real knowledge of the housing market to ensure meaningful variables were chosen.
These features were selected because they directly influence buyer demand and housing value. Location plays a major role as city areas offer better accessibility and job opportunities. The number of rooms and property size affect comfort and suitable for families, while property age impacts maintenance costs. Distance to amenities and income level further reflect convenience and neighborhood quality. Feature engineering was applied to improve model accuracy and reliability. Categorical data like location was converted into numerical form using one-hot encoding. Bedroom and bathroom were combined to reduce multicollinearity. Crime rate was transformed to reduce the impact of extreme values while income was standardized to prevent it from dominating other features. Multilinear regression was chosen because housing prices depend on many variables to simultaneous. This model allows us to clearly see how each feature affects house prices. It is also interpretable, which is important for decision making in real estate investment.
After selecting the model, we train it using Orange data mining. The workflow includes building the regression model, training it with selected feature, and evaluating its performance using several error metrics to ensure accuracy and consistency. The regression model was built using the linear regression widget in Orange. Each feature was assigned a coefficient showing its impact on housing prices. The model was then tested to evaluate how well it generalized the unseen data. This equation represents how housing prices are predicted using multiple features. Each beta coefficient shows the contribution of a specific feature, while the error term represents unexplained variation in the data. The model explains about 66.6% of the variation in housing prices, indicating a strong fit. Error metrics such as RMSE and MAE show moderate prediction errors which are acceptable in real estate data. Overall, the model performs well and can be further improved with additional features or advanced techniques.
Now, I will explain the analysis of factors that influence housing price using the regression and correlation analysis conducted in Orange data mining. The main objective of this analysis is to understand how different features affect house price and how this information can help property investors make better decisions. The result also can be looked at in scatter plot at the regression line. Firstly, for transport access, the scatter plot shows a negative relationship with housing price. This means that houses located closer to public transportation tend to have higher price. Better access to public transport increases convenience for daily commuting, which raises demand and ultimately increase property value. Next is crime rate. Based on the graph, there is a significant negative relationship between crime rate and housing price. As crime rate increase, housing price decrease. This is because buyers generally prefer safer neighborhoods, which reduce demand for property in high crime areas. For property age, the analysis show a negative relationship with housing price. Older properties tend to have lower price compared to newer ones. This may be due to higher maintenance costs and aging building conditions that reduce buyer interest. Moving on to the number of rooms, the graph shows a positive relationship with housing price. Houses with more rooms usually have higher price because they provide more living space and are more suitable for families, which increase demands. For income level, the graph shows a negative relationship with housing price in this dataset. This indicates that higher income areas do not necessarily have higher house price. This trend may be influenced by factors such as affordable housing scene or differences in housing development patterns. Next, the relationship between distance to amenities and housing price shows a positive trend. This means the house located further from amenities may still have higher price. One possible reason is that these houses are located in suburban areas with larger land size or quick dress environment, which can be attractive to certain buyers. For location, the analysis shows a positive relationship with housing price. Properties located in more strategic or disadvantaged areas such as city centers tend to have higher price due to better access to service, employment opportunities, and infrastructure. Lastly, for property size, the graph shows a negative relationship with housing price. This suggests that larger properties in the dataset may be located in suburban or less developed areas where land is cheaper, while smaller properties in urban areas tend to be more expensive due to better location.
The analysis through orange data mining use regression and correlation method to identify multiple factors which impact housing price value. The research findings demonstrate that crime rates produce a major negative effect on housing value because safer neighborhoods always receive better property value assessments. The availability of public transportation service creates a notable influence on property prices because accessible transit options generate higher demand, which increase property market value. Prospective property investors need to select investment properties which exist in safe neighborhoods that also provide access to public transit because this element create attractive market that generates steady investment return. The model needs additional data which should include economic indicator and interest rate and future infrastructure development plans to achieve better predictive performance. The present dataset fails to include three factors which could affect housing demand and price pattern in the market. The implementation of advanced nonlinear regression models would enable a better understanding of complex housing price factor relationship, which would produce more accurate housing price forecast for real-world situation.